In example 1b, the equation we are trying to solve is e raised to the x squared power is equal to 200. First thing we need to do is recognize that this is an exponential equation, okay? The variable here is x, and x is located in the power or the exponent, okay? So we need to follow the plan that we have outlined for solving exponential equations, okay? First thing we need to do is isolate the exponential term. So e is the quantity that's being raised to the x squared power. E is the base here. This is the exponential term that I've highlighted in yellow. It's already isolated for us. Okay, but remember, if it hadn't been isolated, like if we had a 4 multiplied out front, the first step would be dividing off that 4. Okay, when you start solving these exponential equations, okay, you need to get the exponential piece isolated, okay? So the e raised to the x squared power is already isolated, so we can proceed, okay? The right side of the equation is just a number, okay? So what we're going to do, since the exponential piece has already been isolated, we proceed by taking the logarithm of both sides. Okay, so again, you can use ln or log. That's the recommendation. Here it is preferable to use ln. And why is that? Well, because our equation involves e, and we know that e and natural log, those guys undo each other. Okay, so we're going to start by taking the natural log of both sides. Okay, remember, when you are solving equations, whatever you do to one side, you have to do to the other. Okay, so since we took the natural log of the left side, we have to take the natural log of the right side. Okay, so remember why we do this. We take the logarithm because once we've taken the logarithm, that's going to allow us to apply the third major rule of the third major property of logarithms. On the left side, we now have the logarithm of something raised to a power. So we're going to be able to bring the power down in front. Okay, so in our next step, we're going to write the left side of the equation as x squared times the natural log of e is equal to, the right side is going to be the natural log of 200. Okay, a quick note, on the right side, when you're taking the natural log of 200, it is incorrect to write 200 ln. Okay, that doesn't make any sense. Okay, so if I type in 200 natural log, that doesn't make any sense. Okay, the natural log is an operator. Any logarithm is an operator. It operates on what comes after it. So just a little blurb here, make sure you're always writing the logarithm like to the left of any number or expression. It operates on what comes after it. Okay, all right, continuing on. We're happy now because the x squared, the variable piece, is out of the exponent. Okay, so it's going to be a lot easier to solve for x. Okay, so if we work on the left side here, there's nothing we can do with x squared at this point. But remember, we learned with one of our properties that the natural log of e, let me go back, it's on page 3. Okay, we learned right here, I'm drawing an arrow to it, natural log of e is 1. Okay, so the natural log of e is 1. Okay, so we end up with x squared times 1 on the left. That's equal to the natural log of 200. Natural log of 200. Remember, the natural log does something to the 200. It's going to be a nasty decimal, so we're just leaving it as natural log of 200. So on the left, we're going to get x squared. That's equal to the natural log of 200. Okay, so we need to solve for x, not x squared. Okay, we have to keep going here. Okay, we're almost done. All right, so let me rewrite this up here. Okay, so far, this is how far we've gotten. We're at the point where we have x squared is equal to the natural log of 200. We need to solve for x. So to undo the x squared, we need to take the square root of both sides. Okay, because the square and the square root cancel. So one thing you've got to remember Whenever you're solving something like something squared is equal to a number, and you solve by taking the square root of both sides, you need to put a plus or minus out front. Okay, why? Just think of something simpler. If we had x squared is equal to 4 and we were solving that equation for x, remember, not just positive 2 works here. If you do 2 squared, yeah, that's 4. But also, if you square negative 2, you also get positive 4. So my point is, when you're solving something of the form, x squared or something squared is equal to a number, and you take the square root of both sides, you need to put a plus or minus on the right side, because the positive version of the number as well as the negative version of the number will be a solution. Okay, so on the left side, the square and the square root cancel. And so x is going to be plus or minus the square root of the natural log of 200. Okay, this is the exact answer that we're after. Okay, and you can see that we have two solutions here. Okay, because of the plus or the minus. Okay, so what we're going to have to do now, since we have the exact answer, I need to go a step further, and I'm going to get a decimal approximation to the nearest thousandth. Okay, so I'm going to go to my calculator. I'm going to type in the square root of the natural log of 200. Okay, and here is our decimal approximation. Okay, so if you see where my arrow is, one place after the decimal point is the tenths place, then you have the hundredths place, and then you have the thousandths place. Okay, so we're going to be rounding. We need to focus in on this 1. There's an 8 after it, so we need to bump this up. It's going to be 0.302. Okay, so we're going to round this to approximately 2. All right, x is approximately 2.302. Okay, so we're going to have to say plus or minus, okay, because again, the positive version is a solution, as is the negative version. Okay, so we have our exact answer and we have the decimal approximation for our x values. Okay, one thing I want to point out, and I've done this with the other problems, when you have an exact answer, you want to use the notation x equals. And then when you do your decimal approximation, it's not the exact answer, so you need to use an approximate symbol instead of an equal sign. Okay? All right, now I'll put a little FYI here just to remember that if you have something squared equal to a number, you need to, when you take the square root on the right side, you need to put a plus or minus out front. Okay, moving on to part C. Okay, now our equation looks a little more complicated. We're trying to find the value or values of x that make this a true statement. This is 3 times 2 raised to the x minus 2 power plus 1 is equal to 100. To start off, you need to recognize that this is an exponential equation. Okay, when you look at this, find the exponential piece. Okay, you see the x in the power. Okay, so that's hinting that this is exponential. What is being raised to the x minus 2 power? Only the 2. Okay, 2 is the base here. 2 is being raised to the x minus 2 power. That 3 is just hanging out front. It's just being multiplied by this blue piece here. Okay, so I don't see any other x's in the equation. Okay, it is definitely exponential. We need to isolate this exponential piece that I've highlighted on one side of the equation. We need to get it by itself. So we have some extra noise on the left side. We've got the times 3, we've got the plus 1. We need to get rid of that stuff. Okay, so I'm trying to first get this 2 raised to the x minus 2 power by itself. So the first thing I'm going to do is get rid of the 1. Okay, I'm kind of doing the order of operations backwards. Okay, so I'm going to get rid of the 1. Since I'm adding 1 on the left, I'm going to subtract 1 from both sides. Okay, that's going to leave me with 3 times 2 raised to the x minus 2 power is equal to 99. Okay, again, we're after getting this 2 raised to the x minus 2 power alone. So now we've got to get rid of the 3, okay? The 3 is not raised to the x minus 2 power, like I said, so we've got to get rid of it. Since this exponential term is being multiplied by 3, to undo that, we need to divide off the 3. Whatever we do to one side, we have to do to the other, okay? So now the 3's will cancel on the left, and so that will leave us with just the exponential piece, which is what we want. Okay, so we're going to have 2 raised to the x minus 2 power is equal to 99 divided by 3 is going to be 33. Okay, so now we're exactly where we need to be. The exponential piece is isolated. Okay, now that the exponential piece is isolated, this is when we can go ahead and take the logarithm. Okay, the base of the exponential here is 2. So again, you might be tempted to use log base 2, and that is fine, but I do recommend using either natural log or log because those buttons are readily accessible on your calculator, okay? It doesn't matter if you use log or ln, just pick one and be consistent. We did ln last time, I'll use log this time, okay? So we're going to take the log of both sides, so the log of 2 raised to the x minus 2 power is equal to the log of 33. Okay, again, we do this because taking the logarithm creates a situation where we have the log of something to a power. And so by that third major property of logarithms, in the next step, we're going to be able to take the entire power and bring it down as a multiplier. Okay, so in the next step, the entire exponent, and I'm putting it in parentheses here, comes down, and it's going to be multiplied by the log of 2. Okay, so that's what the left side turns into. The right side, we're not doing anything with it right now. It's going to remain the log of 33. Okay, now the log of 2 is just going to be some nasty decimal if you were to put it in your calculator. So we're just going to leave it as the log of 2. Same thing is true of log of 33. It's a nasty decimal. Just leave it as the log of 33. Okay. The x is out of the exponent. It's going to be a lot easier to solve. Okay. So we need to isolate the x, okay, to solve for x. But you're subtracting 2 from it. You're multiplying by this quantity log of 2. Okay. Log of 2 is just a number. Treat it like a number. Okay. What are you going to do next to get x by itself? Well, since this quantity x minus 2 is multiplied by the log of 2, I'm just going to divide off the log of 2. Okay, it's just a number. Okay, so on the left, the log of 2 will cancel with the log of 2. That's going to leave x minus 2 is equal to the log of 33 divided by the log of 2. Okay, so on the right, you're dividing two logarithms. Okay, that's just going to be an ugly decimal. Okay, x is almost by itself. Okay, so on the left, we have x minus 2. If we want to get the x by itself, we just need to add 2 to both sides. Okay, so that's going to give us our final answer. Okay, so I'm going to write over here, x is equal to the log of 33 divided by the log of 2, that quantity plus 2. Okay, here is your exact answer. Okay, exact answers, a lot of the times they look crazy like this. Okay, just leave it alone. Don't second guess yourself. Okay, we will go to the calculator to get a decimal approximation. Okay, type it in exactly like you see it. Okay, so I'm going to have the log of 33 divided by the log of 2. Okay, and then take that quantity and add 2. Okay, so here's your decimal approximation, and we need to round it to the thousandths place. So we have, after the decimal point, we have tenths, hundredths, thousandths. So we're concentrating on this second 4 here. There's a 3 that comes after it, so we're just going to leave the 4 as a 4. So our answer as a decimal approximation is 7.044. Okay, so we'll go ahead and write that down. X is approximately 7.044. So we've got both our exact answer and our decimal approximation for this particular equation.